All right, welcome to another exciting video about software estimation and measurement. Today we're going to be talking about response time and availability. This is based off of Chapter 9 of Software Measurement and Estimation. Today we're going to be talking about measurement of deployed software, namely its response time. And then additionally we're going to talk about availability of software. So let's start by talking about response time. Okay, so response time is really a latency metric. Okay, all right, let's make sure we define terms. What does latency mean? This is taking a while. That was a pun, kind of. I don't know, maybe it wasn't. That was a humor. Okay, good. Thank you. You got my humor. Okay, grade plus.
We missed your humor last week.
So the Oxford Dictionary defines it as the delay before a transfer of data begins following an instruction for its transfer. Okay. That's the Oxford Dictionary. Okay, so it's the delay before a transfer of data begins after we've said we wanted the transfer to occur. Okay, so it's an elapsed time between two events. We're going to talk about what those two events are. There are, in general, three types of analysis. First one is analytical performance modeling. Okay, and this is using mathematical models. Another approach is using simulation modeling, and this is using tools. And the third one is performance measurement, and this is using specialized tools and is based on direct observation. Okay, so what then is the definition of response time?
The time in which the result is generated.
Okay, the time in which the result is generated. Let me put the book's definition up here. Interval between, so between means two different events, between a user's request and the system's response, which is basically what you've said. Okay, so the interval between a user's request and the system's response. So let's have a response time model. Let's kind of show this graphically. Let me go get my diagram here. Okay, so here we have some fancy ASCII art. Okay, fancy ASCII art here. So we have on this x-axis we have time, and we have the user request coming in at this time, and then we have the system response at this time. Okay, so so when is that user request? Like, what has happened at that event? How do we know that the user request event has happened? It's kind of a big question. Let me see if that was clear enough. Like, is it when they start typing? Is it when they click submit? So it's kind of ambiguous, right? This diagram doesn't really flush that out. So let me give you another diagram. Okay, so let's expand this. So now we have the user starts the request, user finishes the request, we have system start execution, we have system starts response, we have system finishes response, all along the x-axis. Then what we have is the reaction time is generally from when the user finishes request until the system starts execution. That's reaction time. But we're talking about response time. So response time is when they're done to when the system starts to respond. Okay? But response time 2 is the user finishes the request and the system finishes the response. Okay? So when you think of response time, how do you think of it? Do you think of it as response time number 1 or number 2? We have a vote for 2? 2? Okay. So I'm going to say typically we use response time number 1. Okay, unless it's a long transaction, and then it's like, well, that's great that you started, but I really need you to complete before it's done. I think like in my mind, maybe I think of response time 2 because it's it depends on the situation, right? If it's like, oh, okay, they're working on it, they're getting back to me. If your professor says, thank you for your question, I will look into it. Well, that's how long they took to respond. That was they started. And then it's, okay, I have the solution. Well, was that 24 hours after? And so the response time, and it depends on how you're measuring it. Are you measuring it for like satisfaction and you're going to lose the user if you don't do something? Okay, well then that needs to be starting. But is it, you're trying to get the user to stay involved after a while? Well, that might be completion. So I can't remember exactly what it was. This was about 2 decades ago. That maybe 15 years ago, that there was a software package, like it was either WordPerfect or Adobe Reader or something like that, a major software package that had a major release. And the only thing that really changed, according to this anecdotal evidence from my professor, was that they put up the splash screen, the screen that says, hey, I'm starting. They put it up right away instead of loading a whole bunch of things and then put it up. That's the only thing they changed. Why would they release a new version with just that change? How do you feel if you say, okay, start up this program, it doesn't start up for 30 seconds? You're like, man, this program is so slow. But if you click start and it goes doop, and then all of a sudden it splashes up, you're like, okay, that's good, Even if it takes the same amount of time, you at least have some feedback that it's doing something, okay? And then you're like, oh, okay, it's working. Otherwise, you're like, man, this doesn't work. Oh, finally it came up. Now, I might blame that on the operating system, because it's like, oh man, my disk is slow or something. But so it'd be great if I could find the hard evidence on that, or the story on that. Welcome. All right, so let's talk about response time specifications. So you've got some options here. What if the specifications said less than 8 seconds? That's option 1. Option 2 is they say less than 8 seconds, but they clearly define that as measured from the user submit to the system starts response time. Okay, is that an improvement? Okay, it makes it more clear. Okay, well, what are we talking about? Because we've had some different definitions here, just in this small group here, of what is response time. What if the specifications were an average of less than 6 seconds with a maximum of less than or equal to 30 seconds as measured from the user submit to the system start response time? Okay, that provides, okay, well, now we don't just have a, are the first ones talking about averages? Are they talking about maximums? Are they talking about 90% of the time? It's kind of unclear of what's going on. Because you could argue, hey, I got the response time down to 7 seconds most of the time. And your boss might be happy with that. She might also say, no, it can never go over 8 seconds. Whoa, that's a different requirement. Another way we could say this is we could say, okay, 95th percentile. Let me write correctly. 95th percentile needs to be less than, we'll say, 8 seconds. Oh, I deleted that from here. And then maximum or 100 percentile is less than 30 seconds. Okay, well that defines more accurately what are we talking about when we mean average, or what are we expecting. So this is almost all the time 95th percentile. So that means 95% of the cases complete in less than 8 seconds is what that means. This says 100% complete within 30 seconds. Okay, so we will not tolerate more than 30 seconds as designers, but we need to almost always take less than 8 seconds, okay, is what this specification says. So I would submit that the last one is the clearest in terms of expectations, and it's both for, you can imagine defining this in a meeting with a client. They said, well, we want fast response times. Well, what do you mean by fast? You know, can you tolerate once in a while taking a long time? Okay, 1 in 20 times we can tolerate 30 seconds. Okay, well then that's something, because that could be a very different system. So let's talk about typical response times. So the engineering rule, the typical response time is 7 seconds. Okay, and we need to specify for what? For transactions and web-based systems. Okay, so if we're dealing with transactions or web-based systems, about 7 seconds. What do you think about when you hit up a website? 1, 2, 3, 4, 5, 6, 7. What do you think?
Then
Less than 7?
yeah.
It depends on the website.
Depends on the website? So you have a different tolerance for like your banking versus a news website versus a university website? I'm not saying there's a right answer here. I haven't stopped to think about these issues. Like, do I hold different websites to different standards? If it's so that's something to think about. What about different programs? When you're working in a spreadsheet versus a Word document versus a game versus some scientific software or something like that, do you have different thresholds for response time? Okay, so something to think about. So 7 seconds has been what it has been for decades. Now, since like the 1970s, 80s, that's kind of been the 7-second rule. So do you think users expect or will tolerate less or more response time now? Like, as time goes on? Are expectations changing?
Their expectations will obviously increase. They won't decrease because they wouldn't want to wait for a longer time. So probably they'll want it more quickly.
Okay, I would agree. Usually expectations increase. A counterexample is actually availability of your telephone. So it used to be you pick up your phone and you'd be shocked if there wasn't a dial tone or you wouldn't get a response, right? But now we have cell phones that, no, hold on. Oh, I got a signal over here. Do you realize that? We went from a landline, which is almost, very high availability, to then moving to cell phones that, my cell phone's out, and that was acceptable. Now, given we traded for non-mobility for mobility, so we tolerated, some outages, but that was just something that I thought, and the quality is different. I'm sorry, can you say that again? You're breaking up. That was just this morning with a student. I was like, well, I'm on the university system. This is probably her cell phone, was my guess. And I get it all the time too, because my wife's like, I can't hear you. I was like, sorry. Anyway, so that's just food for thought. So that's for transactions and web-based systems. Whereas there's another typical response time, and that's 2 seconds, and this is for simple transactions, okay? Simple interactions, okay? So those are two guiding principles. What if we have something that's just gonna take longer, a long-running interaction? How can we improve user satisfaction? What could we do? And this is a whole area of research, so, like if you don't have, we're not even gonna crash it. But what could you do to improve user satisfaction if you know it's gonna take a minute or an hour?
Probably display a message saying, thank you for waiting.
Okay, let them know this may take a couple minutes. What could be even better? That's a good first start, because then instead of like, is it working? Why is it taking so long? If you have an expectation it's going to take a couple minutes, and you're like, okay, I'll go get a bowl of ice cream. I'll wait. So what if you provided the progress? Have anybody seen a progress bar?
Mm-hmm.
I mean, you could at least do the spinning wheel hourglass, but what would be better is 5%, 10%. Then you're like, oh good, this is gonna take 20 seconds. So this is gonna take 2 hours. You have some indication of that. And so if there's a way you can monitor it or sample it or something to give an indication. I love software progress bars because they're not linear. You'll be at 5%, 6%, 7%, 50%, 51%. It's like, okay, I get it that, it's kind of hard and different tasks are weighted differently, and they've kind of said, well, this is probably half and this is probably half, and we can measure this and we can measure that. And so it jumps. And then of course, I don't know if you're like me, but it seems like the longest ones are 99. It's like you're so close. How come the last one takes 10 times longer? The last percentage take 10 times longer. Okay? So that's a way to improve user satisfaction, is providing some indication, whether it's just a general, like this is going to take longer than other things, because often the user doesn't appreciate the complexities that are going on. Some complexity, click, I get an answer, click, I get an answer, click, wait, how come it's having to do that? And so let them know, or provide a progress bar. So there are companies that exist that will time and benchmark your response time of your web page or your software. So that's something to keep in mind as you're looking for that. So let's go back to this 7 seconds rule. Who or from what perspective is it measured? Let's be clear on that, because that's important. Who's measuring that? Is that your boss or the client? It's from the client's perspective, from the user's perspective. Okay, and so we'll talk about that as we talk about availability. But it's a system response time. Okay, so when we talk about the 7 second system response time as perceived from the user. Okay, and so the making sure we're clear about what it is. So if you think when you walk up to an ATM, when you go to a website or anything, it's okay. You treat it as a black box, as a whole perspective, to be able to do that. Okay, that's response time. Now let's talk about, is there any questions about response time? Okay, let's talk about availability. Has anybody heard reports of like 99.999% availability? Say a data center, a cell phone network, or a banking institution? We see lots of nines here. Sometimes it's referred to as 5 nines. 99.999 is 5 nines of availability. Okay, what does that mean? What does it mean when the system is available 99.999%?
There's a chance of 0.0001% that it is not available.
Yes. Okay, so it's almost always available except the small fraction that's not available. So what does that mean? Let's calculate that. So what does that equal in terms of hours per year? What does that equal for hours per year? How do we calculate that? You had most of the answer there. So it'll be a little bit clearer if we do this. Okay, 0.00001, 1 minus that. Okay, so that's the percentage of time it's not available. And we take that and multiply it by what? We're
365 into 24.
So 365, if you want to be real geeky, you could do 0.24. 365 times 24 hours per day. We have days per year, hours per day. Okay, so what does that equal?
8.76.
0.0876 hours per year. Okay, well that's kind of hard. How many hours is that? I don't know. I don't think of hours as like 0.08. I know that's small. So let's take hours. Let's go to minutes. Oh, 5.3 minutes. Over what time period?
Per year.
Per year. So let's change this to minutes. 5.3 minutes per year. Okay, so if you said, hey, Dr. Curry, you can reach me whenever you want. I have a 99.999% availability. That means any time I call throughout the year, the sum of all the times I can't get a hold of you is a whopping 5 minutes. That means you don't sleep. Okay? Which is crazy. Okay, you can't do that as an individual. So when a company says we have 5 nines of availability, that means in a given year they have about 5 minutes of unavailability. That's it. Okay, so if your boss said, we're going to provide 5 nines of availability of the system, you should probably go, do we really want to spend that much money? Is that really what we're trying to achieve? And if a company says they have 5 nines, do they really? How do they? Is there some third party that can verify that? Because that's just amazing. If a system wasn't trying to think what system, like Google's not even up that much. They've had problems with their website that's been down an hour like in the last year or two. That's really high. Okay, so let's talk about how to calculate availability. Okay, so availability equals our mean time to failure divided by the mean time to failure minus the mean time to recovery. Okay, so mean time to failure in this case, to put it in a little different context, is frequency of outages, and mean time to response equals our duration of outages, okay? So how long are we up and how long are we down? So it might be easier to put this in terms of uptime and then uptime minus downtime. No, it's plus. I'm sorry. Sorry. Scratch that. So it's the total time, okay? So this is the elapsed time. So this would be like our year, and then how much are we up during the year, okay? So what's a good availability? What do you think?
100%.
Yes, but if your boss says she wants 100% availability,
That would be hard on the employees.
you might just quit then, because it's like, look, I can't. And we'll talk about some issues that play into that. So what is good availability? I mean, that is optimal, but that's unrealistic. I mean, Google doesn't achieve that. Your bank doesn't achieve that. No offense, I didn't even ask where you bank. And so your customer satisfaction, your customer support cannot provide that. 24/7 does not mean 100% availability. The lines are going to be down. There are natural disasters, floods, earthquakes, hurricanes, tsunamis, etc., that will play into that. So what is a good availability?
90%.
90%? Okay. Anybody else want to cast a vote?
99.
99? Okay, so let's look at this table I calculated here. So we've already done this one. 5 nines is 5 minutes and 15 seconds per year. 4 nines gives us a lot, almost an hour. Okay, so if you're at 4 nines, you're basically an hour per year. If you just pull off a little bit from 4 nines, you've got 4.5 hours a year. If you have 3 nines, that gives you a day, a business day. If you pull off 99.8, okay, if we just do 99%, half a week. Okay? And if you're at 95%, that's a couple weeks of downtime over the whole course of the year. So, what is good availability?
99.5.
So it really depends. Are you talking about
Individual.
customer support for heart defibrillators? Well, okay, that needs to be really high. Are you talking about tech support for your toy? Like your kid's toy? Are you talking about your bank? Are you talking about a data center, which is processing billions of transactions? Are you talking about TSYS? And it'd be interesting to see what is TSYS's availability. So TSYS, if you don't know, processes credit card transactions. So if they're down for an hour, their customers are going to be quite irate, right? They cannot be down very much, if at all, and stay in business. I came across this article today. Here's a sobering statistic from the National Archives and Records Administration in DC. 93% of businesses that have lost availability in their data center for 10 days or more have filed for bankruptcy within 1 year. 93% that have lost availability in their data center for 10 days or more have filed bankruptcy within a year. Okay, so 10 days. So
97.
that's 97%. Now that's if they had one blip in a year and had no other. So I mean, we need to be careful apples to oranges. But if that was their only concern, that would be 97%. Okay. So I mean, 90%'s an A, right, in this class. So that's pretty good. But when you talk about availability, if your system is only available 90%, you're not going to get an A on your report card. And so there's this logarithmic kind of function here of course we want to hit 5 9s, but do we really? If you had to put money towards that, would you be willing to support that? Do we need to have that level of reliability? Okay, or can you get away with 99%? And it depends. What are you doing? So, all right. I think we need an exercise to kind of make sure we have an understanding here. What is the availability of a system that is down 5 hours per week? Okay, so let's take a moment. Let me pause this video. Let's take a moment and calculate what is the availability of a system that is down 5 hours per week. And it might help if I scroll back up a little. Okay, so pausing. I'm going to walk around and help. All right. So the availability of a system that is down 5 hours per week. So what equation do we want to use? Availability equals what? So what's our uptime?
68 minutes, fine.
So 24 times 7 minus 5, right? 24 times 7 is 168, in case you haven't memorized the number of hours per week. And now that's the numerator. What's the denominator? 24 times 7. So is that good availability or bad? Let me use my... Uh-oh. Oh, I need parentheses. I was like, it's 47%. That's terrible. Okay. And so 97 equals 97%.
I actually forgot to use the formula. I did it in different way.
Tell me how you did it.
I just calculated the weeks and then I took
Did you map it to a year?
yeah.
Okay. So you said, okay, well, there's 5 hours. So you basically did a table lookup. Is that what you did? You took 5 hours
Yeah.
times 52 weeks.
52, yeah.
It's not exactly 52 weeks.
52. I took 52. So every month has 4 weeks, so 5 hours, like 20 hours.
So 5 times
I forgot to use the form dialect.
365 divided by 7 is 260 hours, and so that's really close to right about 97%. Okay, there's more than one way to solve a problem. Okay, so you're going off of what you knew, so what you experienced. That's good. Okay, so 97% is just if you're down 5 hours a week. Okay, now that's assuming that all 24 hours in a day are equal. So if you are talking about customer support that's 8 to 5 or 8 to 7 or something, well, that's the expected availability. And so then it's how many minutes or seconds during that availability, the expectation time, are you down? So it depends on what you're talking about. Here this is assuming we need 24/7 access, and we're measuring against that. Okay, let's do another one. What is the availability of a system that fails every 48 hours and takes 10 minutes to recover? Okay, what's that one? Fails, let me spell correctly. fails every 48 hours and takes 10 minutes to recover. What's the math on that one?
99.65.
Well, how do we get there? Because if I ask on a quiz, I don't want you to just memorize this. I want you to be able to calculate it for a quiz or for life. So what was the math you used? What was the formula you used?
48 minus 0.167.
48 minus
0.167.
minus 10 divided by 60.
No, it's 0.167. Yeah, that's it. Yeah, that's right.
Okay, because this is hours, and this is hours. And then what did you do?
Divided by 48.
Divided by 48. So the formula is uptime divided by downtime. So our uptime is 48 hours. Our uptime is 48 hours. Our downtime is 10 minutes. Okay? So you're close. Okay? And so,
No, then it should be 48 plus.
yes, sorry. I was like, it's over 100%. Wow, that's awesome. Sorry. Okay, that's how we know we're wrong, is when it's over 100%. So, times 100, so that we're at 99.65 here. Percent. Okay. 99.65. Okay. So, we're at least 2 nines. So those are very different. 5 hours per week versus 10 minutes per 48 hours. Okay. Now we need to explain. We've just been talking in general about system availability, but let's clarify this a little bit. So there's 2 major factors I want to focus on. One is software availability, and the other is server availability. Okay, so if you're providing your software via some platform, a server we'll call it, then how do we calculate the user perceived system ability? Do we add those? Do we divide those, multiply those, subtract those? So this is your software not having bugs, not failing actually, to be accurate. And then this is the system availability. What would be the appropriate math operator there to be able to calculate these? So let's take something to an extreme to understand it better. What if your server availability is 50%? Well, you need a new server, but let's just assume it's 50%. What is, and your software availability though is 100. What would your system availability be? What would the user perceive it as? They'd perceive it as 50%. Okay, what if it's the other way around? What if your software is only available 50% of the time? It just kept having bugs, it took a long time to fix, but your server availability was 100%. What would the user perceive it as? They'd perceive it as 50% because they can't get to it. Okay, so what if your server was available 50% of the time and your software was available only 50% of the time? You need a new company either to work for or a new team, but to kind of take things to extreme, the user is going to perceive that it's available about 25% of the time because of the confluence there. So what that means is we're going to multiply the availabilities. The highest this can be is 100% or 1. The highest this can be is 100% or 1. So your system availability depends on how available is your software that you're doing, since we're taking this from a software perspective, but also about all the system in between. Now, there is some other factors as well. For example, your connection to the server, your internet connection from your server to the outside world. A user isn't going to care if it's the network connection to your server building or your server. They still can't get it. Okay, so and we have less and less control the further away we get away from it. You know, we might be in the cloud for a server. We might be. But those are just things to keep into consideration. So let's just assume, and this is based off an empirical study, that average server availability is about 99.85%. Okay? 99.85%, we're somewhere in between here, so 20 hours, I don't know. Oh, sorry, between these two. So we're talking like 12 hours a year. That's it, that they're down. Okay? So if we assume that, and your target availability, your target downtime is less than or equal to 10 hours per year. Target downtime is less than 10 hours per year. What do you need your software availability to be? How do we calculate that? Okay, so we've chosen our server solution, and it's got 99.85% availability. And we want the target downtime to be less than 10 hours per year. So what is this? This is our input. What are we trying to calculate with this? Or what can we calculate with this? Of the three terms here. Downtime refers to which of those three?
System availability.
The system availability. Okay, so we have now one unknown. We can calculate the system availability. We have been given the server availability, and we need to calculate the software ability. So okay, so first let's calculate the system availability. How do we do that?
It's 0 minus 2.
So, let's see. Oh, we haven't done that. So, 365 times 24, that's hours per year, minus 10. Okay, everything but 10 hours per year, divided by 365 times 24. Okay. So we're looking at 99.89. So that equals 99.89, is that what I said? Okay. So then our software availability equals what? It equals the system availability divided by the server, right? This is algebra. Okay, so that equals system availability was 99.85% and 99.89%.
No, the system availability is 99.
Okay, good, because that okay, thank you. I was like, no, hold on, my punchline's not working out here. Okay, so what does that equal?
1.
Okay, let's times by 100 to get, So to achieve this, we need 100.04%. What's wrong with that? Good luck. You can't do it.
You cannot achieve it with the server availability.
You can't do that with the server availability. So if you're really trying to achieve less than 10 hours per year, you need a different server solution because you're never going to achieve it. Never. Assuming perfect software. Now, if you assume perfect software, you need to have a talk with yourself or your boss about, that. But let me just make sure this is clear. This is impossible, okay? And so we need to understand when something is impossible, okay? All right. We've talked a lot that availability is a user metric, okay? It's from the user's perspective. Okay, so I want to make sure that's clear. Now, we can affect the length of an outage, okay, because it's based on several different factors. One of which is the system complexity. How does the system complexity affect how long an outage is? What's the relationship there? Right. So we're trying to attack what term here? Meantime, we're trying to reduce this term. So as we reduce that term, then we approach 1. So the length of the average, as a system is more complex, it's going to take more to get it back up. If there's a long sequence to start things up, it's going to take a long sequence to restart them. If it's tedious, it's not automated, it's going to take longer. Okay. If it has to connect to lots of databases, as the complexity goes up, the outage increases. It also depends on, like what severity class are we talking about? Is this a huge severity or is it a much smaller severity? Are we talking about outage of several systems, several components, or just a single component? There's also the effect of the support personnel availability. Okay, so how long does it take for somebody to come out and push a button on the machine? If you have to push a button on a machine. Or how long does it take for them to figure out where it is, and if it's the middle of the night? Okay, and then there's also a host of miscellaneous problems. For example, what if you needed hardware from some third party? Well, how fast can they get it there? How fast can they ship it? Or whatever the case may be. Okay, let's do an exercise. Linked here on the web page. Linked here on the web page. Response time. There we go. All right. So I want you to get in teams of 2 and address one of these questions at least. And then I want you to talk about what is the math that goes into these different situations here. Okay. So in teams of 2, talk about these. So I'll let you divide up in teams of 2. If you're online, then you get to do both. Okay, let's just document this. Okay, so we've done this one before. It was, right, 48 hours. So we have our uptime is 48 hours, downtime is 48 hours, plus 10 minutes recovery. So that's 99.65. And then for 2 hours, what do we change? Or plus 2. And what is that? 96 even. Okay. Okay, so notice what happened there. If we had a 10-minute recovery time, we're at 99.65. But if that balloons to 2 hours, then we drop to 96, which is very different than 99.65. So what I discussed with the team that was working on that is, are there things you can do from management and software development stance to prevent this situation and keep it more at this situation? What would be some things you could do? Have you ever found a bug in your own program? So I'm teaching Computer Science 1 right now, and we're talking about files. Files is the first time that you really have lots of bugs. What if the file doesn't exist? What if you're in the wrong directory? What if, the disk is full? And so one thing I teach them is make sure that you can open the file, and if not, report the error. And so if the error is you could not open the file, then let the user know that. So in terms of uptime, if you reported the database was not available, and then it crashed, and you logged that somewhere or emailed or something, your availability is going to be a lot better than something went wrong. And you've got to say, well, let me check this, let me check that, So the more you can do to understand the problem, that can be helpful to recover. What is the problem? The problem is we had a duplicate record in the database, and that's not acceptable. Oh, okay, well, let's figure out the solution to that. What's going on? Or so that's something that you can stress before you deploy, that, hey, look, we want high availability, so we need to make it easy to recover. Another aspect is, how long does it take to boot up? Are there things you can do to optimize the boot up time so that it doesn't take so long? Okay, so 99.65 and 96% are very different. Okay, other group, recoveries take 5 minutes. So what was the math here? Availability, so uptime is 100 hours. We're dividing 100 hours by 100, 100 hours, but what's the downtime? 10 times 5 minutes, right? And that's 99.17%. Okay? Now let's talk about, this is more likely the case, that you have something where you have a whole bunch of small ones and ones that take longer. How are we going to calculate that? Well, we have the same uptime, but our downtime becomes more complex. We have 90% of the time we have, and so we have 10 times, so 90% of the time it takes 5 minutes, but then we have to add in 10% of the time, so that this sums to 100 here. It's weighted times 2 hours. And what does that do to this? 97.32%. Okay, see how that dropped that? Now I put in this third case to say, okay, what if you could whittle down just the 10% of cases that took 2 hours? What if you worked on it, optimized it, thought about it, came up with solutions so that they're more like 15-minute recovery times? And all we have to do is change this to that, and we get back to 99.01. And so we get a much higher recovery time, okay? And so we're back to above 99%, tackling those really bad cases and thinking about how we can get back up. So there are two concepts I want to talk about that can help us get back up. One is degraded mode. What is that? Degraded mode. Degraded mode is one of the best fault-tolerant designs. And what it is only part of the system is down. So you're able to operate with not everything being up, okay? So what would be some examples of that? How could we achieve that? So often this takes partitions. So at various levels, you could have different databases on different servers or something, and so okay, our customer database is down, or our transactions database are down, or our inventory database is down. So we can hobble along and do some things, but not all. Okay, well, that depending on what they're trying to do, it might work better. So if you can make your system to only one component goes down and be able to work gracefully in that, that would work. What was common among my peers as a college student was to take your hard drive and to partition it. One for the user space for all your files, and the other is for the operating system. Because the thought would be, okay, so let's say you have a failure in the place that you have the operating system, that's fine, reload it. But if you have and then that way you don't lose all your data, your class assignments, projects, work, or photos or whatever, in your other partition, you're able to recover because you've put a divider, you've put a partition between the two, and so it allows for errors that are just take up the part of your operating system partition. You can replace that, whereas you can't necessarily replace the other. Those are some examples. Redundancy can help in this area. One last thing is how can we prevent downtime? We can prevent downtime, by having redundancy or failover systems. Another way is software rejuvenation. You're going to say, well, what is software rejuvenation? Well, I'm glad you asked. Okay, software rejuvenation is based off the concept that software, like hardware, ages over time. What do I mean by ages over time? You have memory leaks that accumulate, we have storage fragmentation, we have round off errors, etc. And so what software rejuvenation means is that we're going to have system restarts. Okay? Has anybody called tech support or been tech support? What's the first thing they're going to say? Have you tried restarting the program? Why is that? Because their product has been tested the very most from the very beginning, initialized. So when my router or my modem has a problem, I don't sit there, I don't pull out a voltmeter, I just power it down and power it back up. And you know what? It works. Assuming I have internet, because something went wrong. I don't really care to know what, I just want it to work. And so software rejuvenation is to restart, to do a system restart. Now, what if my router every Sunday morning at 2 a.m. restarted itself? What would be the net effect of that? I'd be really upset if I was doing something important at Sunday at 2 a.m. But assuming I wasn't, that would mean it would reduce its aging by resetting itself. And so if there is some bug that is extremely hard to track down, this confluence of all these events, etc., that if it reset once a week, then it would have that advantage that it would never age. And so then while it will take it a minute to go down and come back up, that's a lot less than it being down, I'm having to discover it and then pull it back up. So you can do that in software as well. Okay, so you can also do system cleanups. You can look at different resources and proactively take care of them. This is partial rejuvenation. And you can do application restarts. This is also partial rejuvenation. So an application restart might be, you could do a client server model and say, or you could have multiple threads and you could say, wow, that thread's taking a long time. Let me just restart that thread. Okay, so now your system is up and you're saying, this isn't, something's going wrong with this thread. Let me just kill it and get a new one. Okay, well that took a little bit of time, but a lot less than waiting for a user to say, something's not right here, and be able to restart it. That's what I have for today. Any questions?